Hello, good day, everyone. Welcome to our new session for math tutorial. Today, we'll be talking about factoring quadratic trinomial in the form of ax squared plus bx plus c, where a is not equal to 1. Let me emphasize that a is not equal to 1. Among all factoring expressions or equations, this is, I think, the difficult one where students sometimes encounter it like very confusing, but actually they're just confused because they're not yet master on the method to factor such trinomial. This time, I'll introduce an easy way. Okay. All right. So before we do the process that I wanted to show, we will recall first some possible problems that were actually we used to apply factoring. Yeah, you can encounter it in your grade 8, grade 9, and in grade 10, even in higher um, grade levels, right? In senior high and in your college, you can still apply it because a lot of functions, equations you'll be dealing with, and then you apply factoring, you can solve it. Yeah. For example, letter A. The problem is asking you to factor the expression or the quadratic trinomial. Sometimes it's just called expression, but usually it's called quadratic trinomial. Okay, and the expression is 3x squared plus 5x plus 2, and you are asked to factor that. You're very expert. I guess it's in your grade 8. In your grade 8, you do that. And when you were in grade 9, I think you are dealing already with quadratic equations. Yeah, quadratic equations. And you are to find the solutions of that quadratic equation. And I think you were introduced to different methods, and one of the methods again is factoring. Then you come to encounter quadratic functions. Still in grade 9, I think, grade 9 and grade 10, under the polynomials. Quadratic functions, wherein you are to factor, just like f of x is equal to 3x squared plus 5x plus 2. They look like the same. We just write it in different ways. An expression, an equation, and in function form, or function notation. When, okay, yeah, you are told to factor, you are told to find the solution, and you are told to find the roots since it's already a function. So you're solve for the roots of this quadratic function. Okay, and then one method is factoring. So by factoring, now let's take note of that one. That means factoring is really important. We are not just up until factoring. We can use it to find solutions, find the roots, and even find zeros of polynomials. Now, let us review. We used to factor quadratic trinomial in the form ax squared plus bx plus c, where a is not equal to 1, meaning a could be a 2, 3, or so on and so on. And it could be negative, right? In either, yeah, what we usually do in our classroom is doing the trial and error or factor it by grouping. And it's introduced to us by our teachers, of course, our math teachers. And we're able to factor. Example, we are to factor 3x squared plus 5x plus 2. And then we're going to use trial and error. And then you're told by your teacher, okay, you follow the steps in doing it by trial and error. First, you have to factor the first and last term. So you are to take the first term, which is 3x squared, and you have to factor that. Your factor for that would be 3x times x. Then you would then factor your last term because according to the step, you have to factor the first and the last term. So your last term is 2. So that is 2 times 1. Now you proceed to step 2. Write the possible pair of factors. See, your factors are quantity 3x plus 2 times the quantity x plus 2. How we got that? You get first the first factor and then pair it to the other factor in the last term. That's why you have 3x plus 2 and then x plus 1. Okay? And you can also draw or write another set of factor, okay, possible factor, like 3x plus 1 Okay, 3x and 1, you put together 3x and 1, I mean pair together, and then you have x and 2, so x plus 2. All right, so that's it. After that, you have to check the middle term. So check the middle terms using your FOIL method, your basic way of multiplying binomials, right? Multiplying binomials. So we have here 3x plus 2 times the quantity x plus 1. The first set of factors, tentative factors. So you multiply 3x by x, you have 3x squared, 3x times x, and that's it. 3x times 1 is 3x, and then you proceed to 2 times x is 2x, then 2 times 1 is 2. Therefore, its middle term, when added now, the two terms added, 3x plus 2x is equal to 5x. Then we'll try the other set of factors. Quantity 3x plus 1 times the quantity of x plus 2. So we multiply using the FOIL method. So 3x times x is 3x squared. 3x times 2 is 6x. All right, 6x. And then we have 1 times x is x, then 1 times 2 is 2. Therefore, if you add 6x and x, it's 7x. Since our given is 3x squared plus 5x plus 2, we will look into these two answers, 5x and 7x, which one is correct and the same. So you see it's 5x, therefore we're gonna choose these factors, 3x plus 2 times the quantity x plus 1, as our final answer. Then you can write the answer that way. So here's the easy way actually, guys. Now let me introduce it first this way, so it will become comprehensive before we proceed to just like a quick way. Okay, first let's take the example above, the one that we do a while ago. Factor 3x squared plus 5x plus 2. Okay, here we write the first term twice, so it's part of the technique. Okay, we write the first term twice, but do not include anymore the power or the exponent, so you write 3x and 3x. Next you do is multiply your a and c, that's why it's highlighted here, 3 and 2, that's the a and c. Then find factors of that product whose sum is equal to the middle term coefficient. Our middle term coefficient is 5. So in our given, 3 times 2 is equal to 6. And if you factor that, you can have factors 3 and 2, which when you add, it would be 5. Okay, it's equal to 5. Now here's the technique. Diba we write twice 3x, so we'll make a fraction. We'll write a fraction wherein our denominators are our factors of our number 6, the product of 3 and 2. So the factors 3 and 2 here. So write it down there, 3 and 2. So we have two fractions. And then reduce the other fraction because it can be reduced by 3. This one, I'm referring to this one, 3x over 3. So if you're just using the common number 3 dividing both, so you have x over 1. And then this one is not to be reduced anymore because you only have 3, 1 borrowed 3, 1 3 being borrowed, right? 3x over 2, and it cannot be also reduced. It can't be reduced also. Okay. Now you have x over 1 and 3x over 2. If you copy, now you have actually your answer. Now you're just to write it in factor form. So x plus 1 because it's positive 1, and you can have 3x plus 2 because it's a positive 2. So x plus 1, write it that way, and you have 3x plus 2. Okay, so we'll come to doing it quickly using the examples. So that is just to show you how we did it, but if we can master it already, we can do it quickly and even do it mentally. Okay, let's now have more examples. Take note that this method can help you do the process quickly, and later on can do the thing mentally. Okay, example. We have here factor 3x squared plus 7x minus 6. Okay, factor 3x squared plus 7x minus 6. It's not easy to factor a general trinomial like this, where a is not equal to 1. Okay, here we have 3. Our a is 3 and our c is negative 6. So according to our technique, we will multiply a and c. So you have 3 times negative 6, then equal to 18. What's next to do? What's next? You have to find factors of that negative 18 whose sum should be equal to the coefficient of the middle, which is this time 7. All right, 7. So what are the factors of negative 18 that when added equal to 7? Of course, you can have 9 and negative 2. Positive 9, negative 2. Because 9 times negative 2 is negative 18, but when added 9 and negative 2 is 7. And you can now apply that to the technique. Diba? We just have to copy the first term, excluding the exponent twice to form the fraction. 3x, 3x. Okay, 3x, 3x. So therefore, we borrow 1, 3. 1, 3. And then we write the factors of negative 18 as denominators. So 9 and negative 2. Alright, so we have now fractions 3x over 9 and 3x over negative 2. What is next? Reduce the first fraction to return a 3 we borrow, because we should write only once a 3 because there's only one 3 here. Okay, it's not a 9. Okay, so we reduce it by 3. I mean, the common number is 3. We divide both. So it becomes x over 3. This one we copy only 3x over negative 2. Now you have an answer for the given 3x squared plus 7x is minus 6 is equal to quantity x plus 3 times the quantity 3x minus 2. If you check that, you can do the FOIL method to check whether our answer is correct. But it's obvious that's 9x minus 2x, so it's 7x. That's correct. All right, you may check that using your FOIL method. Now, to let you understand further, you can have the example 2 as basis. Okay, in number 2, factor 8x squared plus 9x plus 1. 8x squared plus 9x plus 1. All right. So what we do is take note. We multiply a and c. So 8 times 1, that's 8 times 1 is equal to 8, positive 8. And then find factors of that 8 whose sum is 9, which is the middle coefficient, right? Middle term coefficient. And we have factors of 8. 8 times 1, all positive because 9 is positive. So 8 times 1 is 8, and 8 plus 1 is 9. Therefore, we can use that. Again, we will write the first term twice to form our fraction, 8x, 8x. Our denominator would be our 8 and 1, the factors of 8. So 8 and 1. Now, reduce the first fraction to return 8 we borrow. We borrow because we have 2 8s here. We only borrow 1 8, okay? 1 8. We need to return it now. So by reducing, we can return that. So 8 over 8 would have become 8x over 8 would have become x over 1. And then copy the 8x over 1. Now you can have complete factors of your 8x squared plus 9x plus 1, which is quantity of x plus 1 times the quantity 8x plus 1. Then you can check that again, whether the answer is correct. You use FOIL method. Okay? And now let's have example number 3. Okay, example number 3. Factors 7x squared plus 33x minus 10. Sometimes the students, if they can see examples like this, they would feel like, oh, it's very difficult. It's so hard, right? And then they're trying to do the trial and error method or the by grouping. Oh, it's too hard. They will say that. Okay, this method will help them answer this, quickly. Now, what to do again? Multiply your a and c. So you have 7 times negative 10. That's equal to negative 70. Then you find factors for that. What are the factors? What are the factors of negative 70 whose sum is 33? So negative 70 is equal to 35 times negative 2. Okay, 35 times negative 2. Why 35 times negative 2? Because our aim is when we add, it will become positive 33. 33 plus negative 2 is positive 33. That's why we choose the numbers. Now, let's do the technique. Copy twice 7x. You write it twice, meaning we borrow 1, 7. And then you write the factors of negative 70 as our denominators, 35 and negative 2. Now you can reduce 7x over 35. That will become x over 5. And then copy the other fraction, the 7x over negative 2. Now you have your complete factors for the expression 7x squared plus 33x minus 10 equals quantity x plus 5 times quantity 7x minus 2. Okay, and you can check that again using the FOIL method. Of course, you can check that. So I think that would be all, except if you will request me to show how we apply the method for quadratic functions, quadratic functions and quadratic equations. See ya in our next episodes of math tutorials. Thank you guys and God bless.